Oh, here we go. So in example 2, it's going to be the same thing. We're just going to add some other exponent rules from the past. These ones include some radicals, some square roots, some cube roots. So how do we write both sides as a power with the same base? So again, we look at our powers chart. Do we have any columns or any powers of anything that have 2, 8, and 2? Well, 2 is basically the smallest number you can get on your powers chart. So the question really is, can you write all of these numbers as powers with a base of 2? And yes, you can change 8 to 2 cubed. And what can we change the cube root of 2 to? So this is another thing that we've learned in the past. We can change that to 2 to the power of 1/3. Now that we've done that, we still don't have a single power of 2 on the right-hand side. So now we're going to look back. What is our exponent law for when we multiply powers with the same base? What do we do to the exponents, right? If you have 3 squared times 3 to the 5, that's equal to 3 to the 7. And when the numbers are whole numbers, it's easy to see, because what does 3 squared mean? It means 3 times 3. And what does 3 to the 5 mean? It means 3 times 3 times 3 times 3 times 3. And how many 3's do we have all multiplied in the end together? We have 7 of them. That's the meaning behind why do we add them if the bases are the same. But the neat thing is that that idea, although we can easily see it with whole numbers, that idea stays true even when we get to fractions and not nice numbers. So if we have 2 cubed times 2 to the 1/3, if I add these 3 plus 1/3, well, I'm going to have to get a common denominator. 3 is 9 over 3 plus 1 over 3. And I get 2 to the 10/3. And once I have 2 to the 10/3, this is the place. So that means x has to be 10/3. If we go to part B, same kind of thing. We're going to look at this. 125 and 625. Are those both powers of something? Well, on our powers chart, I think we only went up to 125 for 5 cubed. So then the question is 625 a power of 5? And if you check, sure enough, it's 5 to the 4. So first of all, on this side, I'm going to change just the numbers. And now I'm going to deal, oh, there was another set of brackets here, sorry, originally. And now I'm going to deal with what can I do with that square root. Well, square root is to the power of a half. And I still have to the 2x plus 1. And on the right-hand side, I'm just going to write 5 to the 4/3. Because what's going to happen, and I could have done this on the left-hand side, is the cube root is going to be the power 1/3, and that 1/3 is going to get multiplied by that 4 and become 4/3. I could have done the same thing on this side, 5 to the 3/2, and you can write this as another line if you'd like. 5 to the 3 to the half will just be 5 to the 3/2. We're not quite done yet. On the right-hand side, we have 5 as a single power. We have a single power with a base of 5. On the left-hand side, we still need to use our exponent law here. Power to a power means we're going to multiply. If I distribute the 3 halves, I'm going to get 3x plus 3 halves. And so now we have successfully got both sides as a power of 5. And we can go, so 3x plus 3 halves equals 4/3. And we need to solve for x. So there's some different options you can do with fractions here if you want. Some people will move the 3 halves over, get a common denominator here, 8/6 minus 9/6. Divide both sides by 3, which is multiplying by 1/3. And we get x equals -1/18. So try questions 9 and 10.